Another application of exponentials is compound interest. We see this all the time with money, especially credit cards or any kind of savings account. They have interest rates. When we're looking at an interest rate formula, we have compound interest. This is not just a simple interest. What compound means is that they're collecting this interest a certain number of times in the year. So P is our principal investment, that initial investment. You don't always see a P there. Sometimes you'll see an A sub 0 to represent the initial amount. But 1 plus my rate, that rate is always a decimal divided by the number of times it's compounded. So N is representing that compounding amount. This one is raised to the NT power. So N times our T is always in years. Example 1 says we have $7,520 deposited into an account at 3.25% APR. That's our annual percentage rate. Compounded quarterly, we want to write the function of A into the amount of time T years later. So A has an initial amount of $7,520. 1 plus my rate, well, the rate is 3.25%. So when I put that into a decimal, that's 0.0325 divided by the number of times compounded. If it's compounded quarterly, that means they're collecting the interest 4 times a year. So our compound rate is 4. Then it's raised to the NT, so 4 times T power. There's our function rule for the amount of investment after T years. So how much money is there going to be in the account after 5 years? Now we're just plugging in 5 for our T. And if I show my work, I'd be doing 1 plus 0.0325 over 4 to the 4 times 5. Plug that into your calculator, and let's see what we get. So 7520 times 1 plus, use your fraction button if you want to, 0.0325 divided by 4. Close that parenthesis, and it's raised to the 4 times 5, so 20. We have 8841.08. Since we're talking about money, I'd round it off at the 2 decimal places. So after 5 years, there's, let's just write it here, $8,841.08. Number 2 has a money market account advertising a 1.25% interest rate compounded monthly. You decide to invest $4,000 into the account. What will the account balance be after 3 years? And then how long does it take to reach 5,000? So we're going to need to create a rule for this. If we invested 4,000, that's our principal amount. 1 plus my rate, well, the rate is 0.0125. But it's compounded, so we're dividing that rate. Compounded monthly means 12 times a year, so I'm going to divide by 12 to the 12t, because it's NT. If we want to know what the account balance is after 3 years, we're just plugging in 3 for t. So A equals 4,000 times 1 plus 0.0125 over 12 to the 12 times 3. Let's see what we get. 4,000, 1 plus 0.0125 divided by 12, and then raise it to the 12 times 3. So there's $4,152.77. The thing about savings accounts is that's not going to get you rich ever. You get a very low interest rate, but it does grow a little bit over time. So how long will it take for the account to reach $5,000? We initially put in 4,000. So I'm solving this out. Let's put it over here. 5,000 equals 4,000 times 1 plus 0.0125 over 12 to the 12t. Because we're solving for an exponent, we're going to need to get the exponential by itself. The 4,000 is outside of the exponential, so we want to undo that by dividing by 4,000. And if I do 5,000 divided by 4,000, we get 1.25. So 1.25 equals, and let's go ahead and simplify this a little bit. So 1 plus 0.0125 divided by 12. That's always going to give us a value that's not pretty, or at least almost always. So we'll have to estimate it for now, but we're actually going to hold that answer in our calculator so that we can use it when we're converting to a log. Because this log is going to say I convert to log base 1.001 of 1.25 equals 12t. So when I put this in here, I need to do log base second answer 1.25. That's given me something where it held that answer. Otherwise, when you do your log base, you'd have to put in here 1 plus, let's put parentheses, 1 plus 0.0125 divided by 12, close parentheses off. And then inside the log is 1.25. That would be fine. Either way is okay to do, but you want to be as exact as possible because we don't want to have to round within the problem. So this came out to be about 214.33 equals 12t. We're still not done because we have to divide by 12. I don't want to use this decimal. I want to use the full decimal. So I'm just going to take that answer and divide by 12, which gives me 17.86. So now finally we have a value. So it would take 17.86 years to reach $5,000. And like I said, you're not going to get rich off of that savings account. But example 3 says, now we want to know how long it's going to take an investment to double if it's invested into an account with a 2% interest rate that's compounded monthly. So let's see what we have to work with. A equals, well, I don't know how much we actually put in there, but let's say I take P times 1 plus my rate. Well, the rate is 0.02 divided by 12 if it's compounded monthly to the 12t. So when I'm really trying to solve this, I need to know how long it's going to take to double. Well, if I put in P, then the amount I have now is 2 times P. Really, it's not going to matter too much because we need to divide by P. And if I divide 2P divided by P, I get just 2 equals 1 plus 0.02 divided by 12 to the 12t. So you could have chosen an initial amount that you wanted to. So you could have said, hey, let's invest $1,000 and see how long it takes to reach 2,000. But either way, when you divide, you're going to get a 2 here. If I convert to a log, you can either put that whole thing in your base, or you can estimate what is that and use your answer as the base. So I'm just going to convert here and do log base 1 plus 0.02 divided by 12. That's the base. It's doing inside the log is 2. And so it would say 416.23 equals 12t. If I divide by 12, let's see what we get. So answer divided by 12 is 34.6 plus 9. So it takes 34.69 years for the investment to double. Okay, so that's our compound interest. We have one other compound interest formula that you'll have to memorize. And this is special because it's compounded continuously only. So anytime you see this continuous interest, you know you're going to use this formula called PERT. It changes it to the principal stays the same, but E is that number that we've seen often with exponentials. So it's that value E, which was about 2.718. It's not a variable, it's just a number. R stands for our rate, still, and T stands for our time. So if $5,000 is deposited into an account earning 7% APR compounded continuously, that's our clue that we have to use PERT. Because if it's compounded continuously, we don't have a number here to put for N because it's not compounded monthly, quarterly, annually, semi-annually. It's continuous, all right? So determine the amount after 15 years. Let's see what we have. We have Y equals, or A equals 5,000. E to the RT. Well, R is 7%, so then it becomes 0.07 T. Determine the value after 15 years. So if T is 15, we'll plug that into our calculator to see what we get. 5,000. Our E to the exponent button is underneath the log, so E to the 0.07 times 15 is 14,288. 0.26 if we round off to 2 decimal places. So you can see it grows a lot quicker when you're compounding continuously. We also had a higher interest rate. In example 2, how long is it going to take for an amount to triple if the invested amount, if it is invested into an account with an interest rate of 5.67%. So it doesn't actually tell us the amount that we initially invested, but that's okay because we can do it just like we started out the other example. So A equals P E, because it's compounded continuously, to the R, so 0.0567 T. If we're looking to see how long it takes to triple, then the amount that we have now is 3 times P. We're trying to get the exponent by itself, which means I need to isolate the exponential, get rid of P. That's outside of the exponential. We would divide by P, which just makes that 3. If I'm solving this exponential, I'm trying to convert to a log. This is a base of E, and when we do a log base E, we just use the natural logs. This becomes the natural log of 3 equals 0.0567 T. I divide by 0.0567, and we see what that is in my calculator. So the natural log of 3 divided by 0.0567 comes out to be approximately 19.38. So it takes approximately 19.38 years for the amount, or for the investment, to triple.